Now welcome back to another video. Now in this video we'll just be talking shortly about the regulation of gluconeogenesis. So how can you regulate gluconeogenesis here? Very simple. In gluconeogenesis here, you regulate it by what? You have 3 steps. You have the dietary step, you have the hormonal step, you have the allosteric step. So that is the regulation of gluconeogenesis. So you regulate it by the normal way. You regulate it by the dietary pathway, the hormonal pathway, and you have the allosteric pathway. So in this one I made it so easy so that you understand it very well. The key factor, you have to understand it very well. You get it now? So now in the dietary pathway, now what happens when you feed, when you just eat, when your carbohydrate level is high? Will your glucose level be high or low? When you just eat, your glucose level will be high, insulin will come, tyrosine will come. So when insulin and tyrosine comes, it favors glycolysis and inhibits glycogenesis. I get it now. So glycogenesis will be inhibited when you feed, but during fasting, starvation, strenuous exercise, you stimulate glycogenesis and you inhibit glycogenolysis. You get it now? You stimulate glycogenesis during fasting, you stimulate gluconeogenesis and inhibit glycolysis. But during first state, you stimulate glycolysis and inhibit gluconeogenesis. But during fasting, what do? You stimulate gluconeogenesis and you inhibit glycolysis. Don't forget. During third state, when you eat, when your carbohydrate level is high, when your blood glucose level is high, your body is doing what? It's calling for glycolysis, for you to break down that glucose to form ATP for you, to form energy for you, and also store that to using what? Glucogenesis. So you are storing due to glycogenesis and you are breaking it down to what? Glycolysis. But therefore you don't want glycogenolysis and gluconeogenesis. You don't want them here because you are feeding. But when you are fasting, you stimulate gluconeogenesis and glycogenolysis, and you inhibit glycolysis and who? Glycogenesis. That is a dietary regulation. Don't forget. Hormonal regulation. Immediately you feed, who will you call? You call insulin. If immediately you finish eating, you call insulin and tyrosine. When you call them, remember I said they bind to GI receptor. When they bind to GI receptor, what are they doing? Immediately they are doing what? Inhibiting gluconeogenesis. They don't want gluconeogenesis, so the insulin will increase what we call protein phosphatase, inhibiting gluconeogenesis. But during fasting, starvation, your body increases what? Glucagon, cortisol, epinephrine, growth hormone. Your body increases all these people to increase your glucose level. So we want to increase your glucose level, not decrease your glucose level, because gluconeogenesis means the formation of what? Glucose from non-carbohydrate sources. Glucagon is needed, cortisol is needed, catecholamine is needed, growth hormone is needed. But when you increase insulin here, you inhibit gluconeogenesis. In allosteric regulation here, what happens here? The prime activator is who? Acetyl-CoA. When you increase acetyl-CoA, what happens? You increase gluconeogenesis. Increase in acetylcholine will do what? Cause a negative feedback on pyruvate dehydrogenase. When you increase acetylcholine, what happens? There will be negative feedback, decreasing with the action of pyruvate dehydrogenase, increasing pyruvate now. Because pyruvate uses what we call a transition reaction. You can watch the video to form acetyl-CoA. So when you form acetyl-CoA and the acetyl-CoA level is high, what will happen? It will be inhibited to inhibit pyruvate dehydrogenase. Say I don't want acetyl-CoA again, pyruvate level will increase and go to form oxaloacetate. So cyclic AMP2 is needed. Why? Because cyclic AMP is very important. Because when glucagon binds to a receptor, it increases cyclic AMP pathway. So when you increase cyclic AMP pathway, you favor the action of what? Favors the action of gluconeogenesis. Also, fructose 2,6-bisphosphatase. Also, fructose 2,6-bisphosphate also stimulate this reaction. I get it now. Why? Glucose 1,6 stimulate glycolysis. So the fructose 2,6 level has to be low in order to stimulate gluconeogenesis. but if it's high, it will inhibit gluconeogenesis. ATP, at high ATP, it inhibits gluconeogenesis. At high GTP, it inhibits gluconeogenesis. At high fructose 2,6 bisphosphatate level, also inhibits gluconeogenesis. So what are the requirements of gluconeogenesis? You have what? You need ATP. ATP is very important because high amount of ATP will inhibit the reaction. So ATP is also needed. Also, 2-NADH is also needed per 1 glucose. You need water. You need CO2 in form of bicarbonate for pyruvate carboxylase, and you also need biotin too for pyruvate carboxylase. These are the requirements of gluconeogenesis. Now, what are the rate limiting enzymes here? The rate limiting enzymes are the bypass enzymes, which is glucose phosphatase. Remember, glucose phosphatase is very, very important. It is induced by glucagon and cortisol, inhibited by insulin at fed state. You get it now? So that is what glucose phosphatase is activated and inhibited. So where it is found in the endoplasmic reticulum of the liver and the kidney. Fructose 1,6 bisphosphatase is another enzyme, but this one now, it is stimulated by what? Citrate. Citrate activates it. Cyclic AMP, high amount of fructose 2,6 bisphosphatase inhibits it. You get it now? High amount of fructose 2,6 bisphosphate inhibits it, but citrate activates fructose 1,6 bisphosphatase. And where is it found? In the cytoplasm. Pyruvate carboxylase, which is the first rate limiting enzyme, very, very important, found in the what? In the mitochondria of the liver cells, is activated by acetyl-CoA. High amount of acetyl-CoA favors pyruvate to be converted to what? Oxaloacetate. ADP inhibits it. PEPCK, which is what? Phosphoenolpyruvate carboxykinase, is stimulated by glucagon and cortisol, inhibited by what? Insulin. It's found in the mitochondria and the cytoplasm of the liver. Okay, now so I've given you the 4 rate limiting enzymes that is very, very important. So the summary here, to round everything up, you have to know that gluconeogenesis forms glucose from non-carbohydrate sources, which we have talked about in my last video. It occurs in the liver and the kidneys. It occurs during fasting, starvation, strenuous exercise, and it uses sources like lactate, amino acid, glycerol, and propionic acid. And it has 3 basic bypass enzymes, very, very important, and is regulated by hormone, substrate availability, and allosteric effectors, and it's essential to what? Increase or maintain the blood glucose level. So I hope it all made sense to you and you have understood what I've talked about now. We have summarized our gluconeogenesis video and I hope you understood it. Yeah, so we are done with glycogen metabolism and gluconeogenesis. So in my next video I'll be talking about HMB shunt. Stick to my next video, watch all my carbohydrate playlists, and you will be very, very intelligent. So med geniuses, keep watching my video, share my video, like and subscribe, and also like all my social media handle in Med Genius Academy. I'll continue to remain your great science tutor Lorenzo. See you in my next class. Bye bye.